Yeah, it's me, Aditya, and today we are going to showcase our FossilNet project, which works on the core paleontological information platform. So, directly going towards our project, what it has. So, first on the launching page or landing page, we will see a FossilNet logo, and going towards down, there are scanners, archives, rectifiers, perspective, eras, and Ask AI. Moving downwards, we have specimen showcase vitrines. What it means in a simple language is we have four models. When we will go into the scanner, we will insert the image. For example, if I insert the image here, I will get something specimen, and if that image matches our four models, like if it's ammonite, then will show then that model will show it's ammonite. Let's see how it going to works and what it is. Sedimentary. So sedimentary is basically exploring the timelines for a new person like me. If I was being new, then it becomes difficult to know what is Cameron era, what is Devonian, what is Jurassic era when it was being. So it was designed for that purpose to know what are the different timelines exactly. Then moving towards archaeological excavation lab. So here we have just added a fun element, eh, just being a brush and a chisel. So when we put it out, we'll see a dinosaur. When we put it out the cursor, we will see a dinosaur there, just for fun. But basically, what it does it predicts the land over which you can excavate the fossils. And moving downwards, so downwards we have the archives where any of the researcher if tell something about their project, their research, then we can move to archives to research out and figure out what it had been said. Now moving towards our project functionality directly. So we have scanner section. When we go to scanner, we have specimen Shazam. So what it exactly means? Upload a digital image or specimen URL or scan live webcam to execute zero shoot vision classification. It uses clip interface core model. What it does? Basically, you can load a file from your system or directly paste a URL, or you can go to live webcam to check whether or in which category the specimen belongs to. Just for a demo, I have created the demo files where we have a URL. So we'll copy it and we'll paste it and see that fossil image has been loaded and we are identifying this specimen. The animation is coming of scanning and our LLM is working, and yeah, it tells us that it is ammonite fossil. Yeah, it's a prediction, so it has given that 90% it is a ammonite fossil. It might be an ancient cell, it might be a non-fossil object. It also predicts the age, like the model suggests the age is 409 to 66 million years ago. Moving down, we also have the 3D reconstruction model of what is ammonoid. You can pause it out and zoom in, zoom out, and check how it looks. We have wireframe grid on, solid model on, and we can move it out around to see how it looks. Yeah, this is the database similarity matrix. What it means? It means how much similar. that how much this fossil we have uploaded, so what kind of similarity it shows. But here the flaw, here the advantage is we get to know white match. Not only just it is 95% this, it is 91% this. No, not only that, but here we get exactly that white matches. If it is reef density, then white matches reef density similarity. If it is shell coiling, then how much percentage it is. Yeah, like a specific version that why it is means the AI is also explainable, not only predictable. Trying something more images to get it out. So I have another sample for it. The samples are created just to minimize the video time. Nothing more. This is another fossil. Okay, the scanning goes, and sorry again doing the same. So it is being predicting that what it is. So it's predicted. It is a trilobite fossil. There are 99.8% chances that it is a trilobite fossil by our model key. And the age predicted is Paleozoic era, which is around 521 to 252 million years ago. Cambrian to Permian era. Yeah. So just like the previous ammonite model, we also have this model. Okay, pauses the rotation. We also have this 3D model, how it looks irrespective of the image, how it is going to look. So wireframe grid is, and this solid model, we can rotate it, we can zoom it. Yeah. Moving down, we have again the similarity matrix, that what category it can be belong to. If it is Facops Rana, then what? It, like Facops Rana is exhibited from the USA OU plus, and if it matches our Facops Rana category, then white matches. Like here, it is showing eye facet arrangement match 92%, and overall morphology 94%. That is why it is being predicted 93.8%. Okay. Now moving towards the next section of our portfolio project. It is archive. It is literature mining console. What it does, so it takes the input, it converts the input into classified entities, which can make our task simpler, and also the research known graph. Research known graph are basically the connection points of that keywords to be to make the to make that content look friendlier for the researcher. So let's go directly to content. I have this content created from the GPT just to test the model and to minimize the time of the recording of video. So we have copied and just going to paste it out. Yeah, pasted it, and let's start. Yeah, it does in a minimal amount of time. So what classified entities it have? Let's first thing I want to tell you is that the green means it is 99% sure. The little orange means it is 80 to 75% sure, and the red like it's red like is it is not, it's 45% confirm, not many not sure. So like we have this field report CGA content of what we have get from the location, what exhibition conducted during June 2026, all that content. And going down, we have classified entities: Cham, Gary Mood, Southern France. The keywords basically related to our text which we have given. And also, it has generated a graph. Moving towards graph, looking very complex, but has a many connections. So, being a little complex, yeah, it is a graph which has been generated by the model, which can be moved separately to get the more clarification of the data. One thing I forgot you to tell about, in this scanner section we also have a live webcam. So if I put it on the live webcam, then it's my face. Yeah, it's me showing out. So let's test our model, how accurate it is, capture it, and identify this fossil, whether I am a fossil or a human. So yeah, we have get the prediction. Safety protocol warning: this object might not be a fossil. It does not exhibit standard paleontological fossil signature. It means the model have predicted that we are not a fossil. I am not a fossil, basically. So yeah, it have the accuracy. Now moving towards our rack paper section. What it is like we have a doc and we just want that doc to be to tell what it has, to summarize the doc, anything about the doc, anything about the PDF. We want it to be convert. Just ingest that document here. So I have downloaded one document of the research. That is this document having the research. Let's open the document if possible. Yeah, I have ingest. I am going to ingest that document here. It is analyzing the PDF, and that PDF is being converted in the chunks. 53 chunks has been created for the file as 41 and out black. So embedding dimensions I have mentioned 384. Now what it is going to do, we are asking about the publication. Yeah, ask about the publication. Semantic index ready. Ask question like what fossils were discovered in the study. I have one question too, just to minimize time. What was the study? What was the, yeah. So I am having that question. What problems are the authors trying to solve? Going to paste it out and waiting for the LLM to get the response. Taking the time as the machine hardware is processing the data. Okay, we have get the result. So what problem are the author trying to solve? We have get the result. The author are trying to solve the problem of understanding the evolutionary history and divergence times of salamandrid era, a family of salamanders that include species such as newst and salamanders. Specifically, they aim to ingest the position of Koila genus of extinct salamanders with the family. Yeah, it has tell us what the document mean about from the chunks. Yeah, if we consider the precision, it's good that it is going to identify what content the document has from the given chunks which the model converted automatically. It's asked another question to test its accuracy. So I'm going to ask another question to summarize the research paper. Yeah, asking that question. searching vector database codes. So basically it converted the file into chunks for easier fetching. Just waiting to get the result. Yeah, we are getting the result. Holding on for getting the result. Yeah, we have get the result. So what our AI curator says is a research paper present a study on the origin and early evolution of salamandrids, a family of amphibians that includes newtons and salamanders. Study was conducted using fossil find from sites in southern France dating back to the late Cretaceous period. Campanian and Maastrichtian. The author used to combination of molecular data. Yeah, it seems that the model has correctly summarized the research paper, not added any hallucination. Yeah, the study has also mentioned that salamanders were likely widespread in the late Campanian man. Okay, and the collections are managed and stored by the CVCU. So yeah, it has predicted this. It has given us the summary of the ingested document, no doubt. Asking another more question, just in grid of testing the model accuracy. Video might seem be longer, but as I need to show and everything, each and everything, how it going to work. So yeah, we have get the result. Study was conducted to further understand the origin and evolution of salamandrids, a family of amphibians that includes newts and salamanders. Author aimed to address the gap in scientific knowledge regarding the timing of the divergence of salamandrids from their common ancestors, specifically the okay. So I think the aim of this study was going to be clear that they are going to research something on the salamanders, and the research paper is about salamander study. That that what point I am getting from the ingested document. You can do another more query if you wish to. But now I am moving to perspective section as the video will go more longer. So what perspective section is? It tells us about hotspot where the Hell formation, where the Burgess shell, or where the current or recent excavation has been done, and where the limestone like fossils have been identified. Like if I click on limestone, we have get that it is found in Germany area, Australia, and it has marked us in the circle, in the dotted circle. If we check Burgess shell, it is telling here that Burgess shell is in Calgary area and Regina. It is being shown by that dotted circle. So yeah, it tells us about hotspot of that shell of any formation of any limestone. Okay, then moving up, we have AI advisor. Like I want to find Jurassic period something. No, I want to find Cambrian period targeted specimens. So I want to find shark tooth continent is suppose Asia. Let's generate AI advisory. So it is analyzing formation. Okay, waiting for the result to get where that fossil can find can be get. Waiting for the result. Hold on, we are getting the result. Yes, let's It has a map integration just to match our theme. It is in the dark. The map is being used by the leaflet. Okay, we have get the result that it is in Mongolia. So what our FossilNet excavation advisor reported to us, it is like the machine comes, the response comes. So what it tells us is requirement formation and specific coordinates near latitude 44.2, longitude 103.7. It is Chenjiga Formation. The Chenjiga Formation located in Yunnan province. Okay. So layer depth recommendation. What recommendation it has given in the middle Chenjiang series or in the lower Chenjiang series, we might get the fossil. And if you have time, you can pause the video and you can go through what it has given depthly. If I am going to read each and everything, that video be longer. It has also tell us logistic advisory that what climate that location might having, what tools we might need. So it has tell us we need a geological hammer, safety helmet, trowels, screwdriver, bushes, and field notebook and camera. And probability of scope of discovery is very high. It has given 7 out of 10 rating, which is good. And also another thing written here, you can go through that what it's telling us. Eras. So just I have tell you in the starting that if someone is not familiar with what are Cambrian era, what are Devonian era, what are the different eras, Jurassic era, what are the different eras, if someone is not going to familiar, then it the timeline makes you familiar about it. It has this. You can pause the video and go through. It tells us how much year old the Cambridge is, the Devonian era is, the Arbonia era is, Triassic era is. You can pause the video anytime to go through it. The Jurassic era is, the Cretaceous era is. Okay, you can pause the video and go through it. That how much climate it have, which fossils were found in that era, how much year old it was used to be, and a little description about that era. Now directly going toward Ask the AI feature. So in the Ask the AI we are having different models. Cubin 1.5 billion train parameter model, up to 3 billion, up to 7 million, and 8 billion model train. So let's ask a question to the model. So let's ask the question to the different models. Okay, I am asking this question to the different models. How do scientists determine the age of fossil? It is generating. It might take few seconds. We have different models. We have selected right now a low train model just to reduce the latency time. Different models are 1.5 billion, Cubine, DeepSync, Mistral. These are completely offline model and Ulama based model. It is generating the response. Holding on for the response. No cut in the video. So video might be longer. Yeah, we have get the response. What it tells us, the fossils are typically dated using this following method: relative dating, stratigraphy, radiometric dating. You can pause the video and go through the content which has been given. It also uses the era. Okay, now let's change the agent. We are switching towards our reasoning agent, that is lip sync. deep sea carbon, asking the same question to deep sea carbon. Waiting for the response as it is 8 billion train model, so it might take a longer time. It is taking it can take a minutes also as the system specs are limited, and that's what the model complexity, the AI project's complexity is begin. For deploying such the projects, we need a good GPU. Yeah, we have getting the result. What that results mean? It also tells us the relative dating, absolute dating with are the methods, and there are epoch. That's epoch. Okay. Now I have another question. What is epoch? What is epoch? I'm going to ask it. Let's see what it tells us. What is the epoch? Epoch. Yeah, if I correctly pronounce it, yeah, it has given the response. So what it means in epoch is a unit of time that is a part of stratigraphic Cronius stratigraphic system used to define and correlate rock strata fossils and sedimentary succession. So yeah, it is given as the what is epoch. Yeah, I think I cover the many topics. Like I have covered the things as much as I can in the query lab on landing page. If we type any query, like if I type sorry, hi, and it directly goes to our LLM. Okay, so yeah, I think I have covered each and everything related to our product, related to our portfolio, related to that fun element, each and everything. Thank you.
Guys, before ending this video, I just want you to show how the practical implementation of the project is being going to work on the real life scenario. Let's suppose I have connected this phone on the network and I'm opening Shazam fossil and just capturing through camera. Okay, so I just switch to the camera and take a photo of the fossil, and yeah, okay, and letting identified. Okay, wait a second, just okay. So I have taken the photo of the fossil. If it is getting, I am going to analyze the species of the fossil. The photo is might not that clear, but it is identified that it is a dinosaur bone, and its age also predicted, its structure also predicted, and yeah, it's predicted. Thank you everyone. I just wanted to show the real life implementation of the project before ending the video. Once again, thanking everyone for seeing the video till last. Thank you. Bye bye.